Hello friends, in this video we will study the various types of capacitive transducers which are based on the principle of change in area of the plates. So let us start with our topic. We know that capacitive transducers are those transducers which measure a quantity by measuring the change in the capacitance. So by any means, if the capacitance of a capacitor is changing due to the change in a physical quantity, then we can use that principle to measure the physical quantity. Now, if we define the capacitance of a parallel plate capacitor, it is defined as so capacitance is given by the equation C, which is the capacitance equals to epsilon A by D, where epsilon is the permittivity of the medium, A is the overlapping area of the plates, now this permittivity of the medium is equals to epsilon naught epsilon R, where epsilon R is the relative permittivity of the medium and epsilon naught is the permittivity of the free space, which is a constant 8.85 into 10 raised to the power minus 12 farads per meter. So this is the capacitance, how it is defined. Now you can see from this equation that capacitance, it depends upon the permittivity of the medium, also on the overlapping area of the plates and on the distance. It is directly proportional to the permittivity and overlapping area and inversely proportional to the distance between the plates. So if we want to change the capacitance, we have to change any of these variables. Okay, so the capacitive transducers, they are based on the principle that the change in the capacitance is caused due to the changes in any of these factors, that is either the change in the overlapping area, change in the distance between the plates, or change in the dielectric medium. Dielectric medium is the material which is between the two plates. Okay, so if we are changing the medium, we are changing the permittivity. So if we make any variations in the dielectric medium, then also capacitance changes. So any changes in these three factors, they are going to change the capacitance, and this principle is used by the capacitive transducers to measure the various types of physical quantities like displacement, pressure, flow, level. All these can be measured. Now here we are going to study the capacitive transducers which are using the change in the overlapping area of the plates for measuring the physical quantities. Now from this equation you can see that the capacitance, it is directly proportional to the overlapping area of the plates. So we can use the capacitive transducers which are using this principle of change in the area of plates for the measurement of displacements which are from very small value to large values. So this type of capacitive transducers which are based on the principle of change in the overlapping area, because capacitance is changing linearly with the changing area of plates. So they are used for the measurement of moderate to large displacements which are in the range from 1 mm to several centimeters. Now let us see the diagram that how the capacitance is measured, or the change in the capacitance occurs due to change in the overlapping area of the plates. So in this diagram you can see we are having two plates. One plate is the fixed plate and another is the moving plate. So moving plate is kept fixed, and the fixed plate is kept fixed, and the moving plate is moved over this fixed plate. Okay, now as this plate is moving, the overlapping area, means this area, the overlapped area between the two plates, it's being changing. Okay, so when this moving plate, it is moved in this direction, means means in this direction it is increasing. So you can see that the overlapping area is also increasing. So as the area increases, the capacitance also increases. Now when it is moved in this direction, okay, so in that direction you can see overlapping area will be decreased. So due to the decrease in overlapping area, the capacitance decreases. So here in this way, the two plates, the parallel plates which are kept over each other, we are having dielectric medium in between these two plates. So as these moving, the plates are moved, the moving plate is moved, the change in the overlapping area is also changing, and due to that the capacitance is changing. Let's see, we know that for a parallel plate capacitor, capacitance is given by epsilon A by D. Okay, now area is what? It is the length into breadth. Okay, now length is W and breadth, width is W, length into width is there, and the length is X. Okay, so here epsilon, X and W, and this is D, where X is the length of the overlapping part and W is the width of the overlapping part. Okay, so area is equals to X into W. So we have put here the value of the overlapping area. Now if we define sensitivity, sensitivity is the output upon the input. Input is changing, means the displacement which we have caused, the length is changing here. So del C upon del X. Here putting the value of C or differentiating the C with respect to X, we will get epsilon W upon D. So sensitivity is equals to epsilon W upon D farads per meter. The unit of capacitance is farad, that is F, and the distance here, X, length is in meters, so farads per meter, and this is the sensitivity. Now in this relationship you can see that the distance is a constant, width is a constant value, it is not changing. Epsilon is also the permittivity of the medium, which is also constant. So we can say that in this case the sensitivity is constant, and hence there is a linear relationship between the distance and the between the displacement and the capacitance, that as we are increasing the displacement, the overlapping area is increased, means displacement in what direction we are moving the plates, the displacement will be in linear relationship with the capacitance. The capacitance will either decrease or either increase. Now, if we see the sensitivity for a very fractional change in the capacitance, for a very minute change in capacitance, so sensitivity will be S dash 1 by C del C by del X. Okay, so here if we see, if we put the value of del C by del X and the capacitance C is epsilon A by D, and del C by del X we have already calculated, it is epsilon omega by D. D and D cancel, epsilon constant, area is x into D, x into W, so W and W also cancelled, and we are left with only 1 by x. Okay, so you can say that sensitivity, it is inversely proportional with the length of the parallel plates. Okay, or we can say the displacement. Okay, so this type of capacitive transducers, they can be used to measure the linear displacements which are in the range from 1 mm to 10 mm with an accuracy of 0.005%. Now this was the case when the capacitor plates, they are in the form of a flat surface, okay, or in the either in the square or in the rectangular shape the plates are there. Now if we are talking about a cylindrical capacitor where the plates are in the form of a cylindrical shape. Okay, so for that, if we see the diagram for the cylindrical capacitors, so in the case of cylindrical capacitors, you can see we are having the capacitor plates in the form of a cylinder. One is the fixed metal block, and inside that fixed metal block we are having the moving tube. The diameter of the fixed metal block is D2 and the inner moving tube is having the diameter D1. Obviously D2 is less than D1, D2 is greater than D1. Okay, so that the moving tube, it can move inside the fixed metal block. So when this moving tube, it is completely inside this fixed metal block, then the overlapping area is greater than is, means it is more Okay, and when this moving tube is moved outside this fixed plate, then the overlapping area will be less. So when the displacement is in this direction, means it is moved outside, the capacitance decreases because overlapping area decreases. And when the displacement is in the left hand side direction, means the moving tube is moved inside this fixed metal block, overlapping area is more, so so the capacitance it increases. Okay, now in this case, if we define the value of the capacitance, it is given by the equation. So capacitance is given by 2 pi epsilon x upon log to the base e d2 by d1, where x is the length of the overlapping part of the cylinders. So this is the capacitance for a cylindrical capacitor. Now in this case, if we find out the sensitivity, again sensitivity is del C by del X. So it will be 2 pi epsilon log to the base E d2 by d1. Okay, farads per meter. So here also you can see that the sensitivity, it is constant, pi is a constant, epsilon is a constant, and then log to the base e, d2 and d1, they are also constant. So here also we will get that there is a linear relationship between the capacitance and the displacement. So in both these cases, we have seen that there is a linear relationship between the capacitance and the displacement. If we draw the graph for this, so you can see that the relationship between the capacitance and the displacement, it is linear. In the starting, we are getting some value, some offset value is there, and it is due to the edge effects. Due to the edge effects present in the capacitive transducer, due to that in the starting we are having some non-linear relationship between the displacement and the capacitance. Now you have seen that these two types of capacitive transducer, they are measuring the linear displacement. Now not only linear but also the angular displacement can be measured with the capacitive transducers. For that, let's see the diagram for an angular displacement measurement. So for angular displacement, we are going to use the capacitor plates which are in the form of a disc. One plate is fixed and another is the movable plate. Okay, and the angular displacement which we want to measure, it is applied to this movable plate. So we are going to measure this angular displacement theta. Okay, in this case, The value of the capacitance will be maximum when the two plates, they are going to completely overlap each other, and this condition will occur when the theta is equals to 180 degree. Now at this point, the value of the capacitance is given by C is equals to epsilon A by D. We know that. Okay. Now here, when they are completely overlapping each other, the overlapping area will be pi r square. Pi r square by 2. So here, because it is a semicircle, for circle it is pi r square, and for a semicircle it is pi r square by 2. So this will be the area. Now the area when the angle, this is the area when the angle is 180 degree. So in that case, when the capacitance at the angle theta we want to find out, so it will be epsilon theta r square by 2d. Okay, instead of pi we are having theta here, and theta is the angular displacement in the radian. So in this case, if we find out the sensitivity, which is del C by del theta, output is the change in the capacitance and input is the angular displacement. So del C by del theta will be epsilon r square by 2d. Here also you can see that it is a constant, epsilon is constant, r is a constant, and d is constant. So sensitivity is constant. It means that there is a linear relationship between the angular displacement and the capacitance. So if we draw the graph for this, it will be like, so linear relationship is there, graph will be linear. So the angular displacement and capacitance, they are having a linear relationship. Maximum capacitance will be measured at the maximum angular displacement 180 degrees. So you can see that this type of capacitive transducers, they can be used for the measurement of angular displacement up to the angle 180 degrees. So here in this video, we have studied about the capacitive transducers, which are measuring the displacement by measuring the change in capacitance, and this change in capacitance, it has occurred due to the change in the overlapping area of the plates. We have seen the case of linear displacement and angular displacement measurement. For linear displacement, we saw two types of capacitive transducer. One was the case in which the plates are in the form of parallel plates are there, okay, in the form of a square or rectangular shape they are. Second was the case when the plates are in the form of a cylindrical and cylinder type capacitor is there. For angular displacement, we saw the case when the plates are in the form of a disc shape. Okay. So I hope that this topic, capacitive transducers using change in area of plates, it is now clear to you. Thank you.